Hello everybody, so today I will talk about the system design of Tinder and I will do the high level design today, like yesterday. And I actually took so much time yesterday, like 30 minutes. Obviously this is too long for high level design, so I will go quickly today. Okay, so I will start with the functional requirement. So Tinder is a dating app. I think it's the most famous dating app. And user can find their partner and user inputs the profile and user can see other users' profile. And if, let's say, the user who is using is a guy and she's looking for a female partner, and if when he looks at some profiles of the girls, and if she looks good, he swipes right, which means like. And if he doesn't like her, he swipes left, which means skipping. So that's the kind of core functionality of the Tinder. And something I should add is also, of course, user can, okay, so in case of the Tinder, which is different from other apps, there is no search functionality. Instead, let's say maybe 30 profiles per day, 30 girls per day are prepared for him, and he has a choice to do right swipe or left swipe for those 30 profiles. I would say stack of profiles. Yeah. And one more thing I should add is in Tinder, we can do the searching, or I should say filtering with the location. I mean the distance from the that user. So that's a kind of unique point of the Tinder. Of course, he can specify the preferred max distance of the preferred distance, max distance too. Okay, that being said, I will summarize what I told. So as a functional requirement, user can create and input the profile and preferences, including max distance. And okay. And also user can see the stack of profiles. Yeah. Which is refreshed. And also user can swipe user can swipe right or left. And I will talk about the matching. So if two users swipe right each other, they match. Okay, and the match should be notified. So I would say match is notified in UI or push notification. So let's say user A swipes right on the user B, and user B already swiped right about user A. In that case, because user A is using the app in real time, he should be notified immediately. So for user A, I'd like to notify the match with in UI immediately. But for user B, probably he's not opening the app. So, or maybe he's using other features of the app. So rather than, this UI notification way, I would use the push notification of the smartphone. And yeah, user can check matches. And of course, user can start the chat, but I don't make the chatting feature the focus of this discussion. Okay, so these are functional requirements. Okay, so I will do the non-functional requirement. So I will start with the cap theorem. So cap theorem is the kind of principle that out of the strong consistency, availability, and partition tolerance, the system can support up to 2 features. Yeah. So and because we are developing the distributed system, the partition tolerance is a must. Without the partition tolerance, when there is a connection loss, I mean there is a disconnection between the servers, the system doesn't know how to handle it. So obviously, it's not accepted. So that being said, I have to choose one from availability or strong consistency. And in this Tinder's context, I can reference this, comparison with. So if I take the availability, if I take the strong consistency, user can always see the latest data, or I should say, the process can read the latest data all the time. And latest data means the data including the latest update, latest write to that data. So the client, or I should say the client process, can always read the latest writes, but instead, if the system cannot return the latest data, the system doesn't return anything and it's not available. But if I take the availability, it means that the system always returns the data, but in some cases it's outdated. It may not include the latest writes. So that being said, for Tinder, I use the kind of hybrid approach. So I want the strong consistency for matching feature. And for others, I choose the availability. And I accept the eventual consistency. So what I mean to say is, for matching, let's say user A likes user B, and immediately before, user B liked user A. In that case, if the kind of process cannot read the like from B to A, if it overlooks it, they overlook the match. So that's the issue, because definitely we should not overlook the matches. So that's why I'd like to guarantee the strong consistency for matching. But for other features, like reading the profile, displaying the profile, description, it doesn't have to be updated. Sorry, it doesn't have to be latest. It's totally fine that if I look at the user A's profile and user A just updated the profile text, but I cannot see the updated text for, let's say, a few seconds. So that's what I mean by this. Okay. And others, let's say, low latency. So I would say 500 millisec for updating the profile to be done, or of course checking the matches, list of matches. So this and this should be within 500 millisec. And I think stack loading, this should be also within 500 millisec. But for swipes, I'd like to make it much earlier because I don't know if this is good or not, but many users, especially guys, keep swiping right without seeing any profile. Yeah. So I'd like to make it possible that swipe and showing the next profile can be done within 100 millisec. Sorry. Okay, so this is another non-functional requirement. Yeah. Okay, and I will talk about the scalability. So for this system, I set 20 million daily active users. Okay, so these are non-functional requirements. Now I will talk about the core entities. So core entities is like the database table names. So I would define what kind of models we need in a system. I will talk about the attribute or something like that later. So we need the user and we need the profile, but let's include profile into the user. So I can say it like this. User has profile and preference and of course location. Yeah, I would put all of them, include all of them into the user model for now. And aside from that, we need stack. But actually, this stack is the profile, list of the profile. And also we need swipe. And we need match. Yeah. I don't talk about the profile pictures. Yeah. Like uploading S3 or resumable upload or something like that. I would make it out of the scope. Okay, so this is core entities. Now I will talk about the API design. So firstly, I will list the names of APIs we need. So firstly, user can input profile and preference, including max distance. So I would say update profile API. So this what should I say? Yeah. Yeah. I think I can separate update profile and update preference, but probably it's not the focus of this design. So I just say update user. But of course, if there are so many profile attributes, later we can split the database profile and preference. Yeah, but for now, I would say update user API. But for location, this is different. So I would separate this because location is updated in a completely different way. So basically, user never updates the current location by himself. It is updated by the background process. Yeah, and periodically, like every 1 minute. So I would add this update location as the other API. And aside from that, user can see the stack of profiles which is refreshed every day. So user has to get stack. Yeah. So I would make it the bulk fetch. So the front-end bulk fetches the profiles to be displayed to that user And for swipe, swipe is just a front end kind of functionality. So it just shows the prefetched profiles to the user as he swipes. So with this, definitely this swipe less than 100 millisecond latency is feasible. Okay, next. So of course we need the swipe. And aside from that, matches notify the UI personification. User can check the list of his matches. So get matches. Okay, this is APIs. I will write the detail from here. So update user API. So I have two options here. So using the HTTP patch method or using HTTP put method. So with patch method, I can update the specific attribute only, like username only or user height only, user preference only. But with the put method, the whole user data should be updated. So the client has to specify, include all the profile data into the request body. And that being said, I'll choose the patch method because we don't have to put all the data into the, include all the profile data every time. So date, and because this system needs the authentication, I include the session token in the header. With this, the backend can know which user ID this user has. And so that being said, we don't have to include the user ID in the API. So I can just say profile and attribute. Yeah. So this should be attribute like name or say maybe height or location or location like the city or, and as I said, I also include preferred, let's say height, preferred race or something like that. Okay, so, and this API should return the 200, yeah, when the update succeeded. And update location API. So this should be put method. And again, I'll do that's the header. So now it knows which user is about for this API. So I use the put location. And this should include longitude and latitude. Yeah, and when the update is succeeded, it returns 200 status. Okay, so get profile stack API. So I would say again, of course, this needs a session token for the authentication, and this returns a list of profiles to be displayed. And for swipe API, I would use the put API because let's say the swipe as the entity mother. So there should be exactly one swipe from one user to another user. So every time user A swipes user B, that user A to user B swipe entity should be replaced. So that's a kind of concept behind this put method. So target user ID and also like or dislike. So this is a boolean is right, and this returns 200 if it succeeds. And if this matches, it should return notify that to the user. So I should include the is match boolean. Yeah. So with this, the front end can render the kind of you know UI which celebrates the user that he matched. Okay. And get matches API. So this is a bulk, API. So this should return match, list of the match. Okay, so these are API design. Okay, so now I reduce the high-level design. So from the learning of yesterday, I should make it as simple as possible. Otherwise, it takes 40 minutes. So user makes a request to the backend. So this is the API gateway. So I'll choose the microservice design. Yeah, there's so many reasons. For example, I'd like to make the separation of the domain clear, and also I'd like to, keep the, let's say, chatting service working even if the matching service doesn't work. So about the update user API, user makes the request to our backend, and this makes the request to our profile service, and I assume that profile data is already created for this user when he logs in. So I put the user data in profile DB. Sorry, I update the data in the profile DB. And so profile DB should have the profile, or I should say user database. So this should have height, race, something like that, and also what was it? Preferred height, preferred race, or something like that. So with this, we can update users' profile itself and also preferred condition. So this profile service makes a query to update the profile DB and returns the successful result to the user. And for now, I'll choose the PostgreSQL, as the default. But I will update this if this doesn't scale or if it doesn't work for some reasons later. So tentatively, I chose PostgreSQL. Okay, and because as long as this user table has the primary key in this user ID, the query, DB query can update the record with all login time, so with B3 index, so this is so good. Okay, next update location. So I would create another service here as a location service. This is because this location service has a different access pattern. So profile service is not updated so often, probably compared with location. But for location, as I said, for each user, every 1 minute, location is updated. So I separate the DB, sorry, service. But for now, as I said, I put the location here in the user table. So this location service updates the latitude and longitude in user table. Of course, there is a kind of discussion that this location service, this location request heavy loads this database, but I will talk about that problem later. And next is get profile stack API. So I create the stack service. So what happens is when there is a user who'd like to get the stack of users to be displayed to him, this stack service makes a query to this profile DB and gets the list of users, let's say 30 users, which matches his preference. But obviously this doesn't work because this query is really complicated. And also this includes the filtering with the location. Sorry, so I need preferred max distance to. Yeah. So I will update this. So instead of, throwing the query and filtering with on spot, I would pre-calculate the stack. So stack generation current job. So this is a daily job because as I said in the function requirement, this should be refreshed every day. So this stack generation service reads the data from this profile DB, and for each user, it creates the stack of users and save it in the stack DB. I use the PostgreSQL again. So I need the user and let's say the other user ID, which is oh wait, so this is stack profile. So this is swiper user ID, swipe user ID. Yeah. Okay. So with this, maybe we need to create it add. So this stack generation daily job creates the stack profile record. And now this stack service just have to read from this, read from this stack DB. Okay. So with this partition, with this index, so this filtering with swiper user ID takes overlogging time thanks to the B+3 of PostgreSQL. So this works. of course, for stack generation daily job, I need the partitioning or something. It doesn't work with only one single server because there are so many users. But I will talk about that, partitioning later too. Okay, so next is swipe API. So again, I create another service here. So this is, yeah, same RE because of the access pattern. So swipe is, of course, very intensive, write intensive. So which is different from other servers, other services. So I separate them and let's put swipe, create swipe DB. So when the swipe is created, I mean, when user makes the swipe, this swipe API is hit and it persists the swipe record in the swipe DB. So we need the swipe from swiper user ID, swipe user ID, and is right or not, Boolean. Okay. Yeah. And also, when user swipes, we have to notify if he matched or not. I will create the match record here. So I'll just say user ID 1 and user ID 2. And I'll choose PostgreSQL as the default, but maybe I will update later. Okay, so this is a match record, and yeah. So there is a kind of discussion if we should create match record, two match record for the actual one match. So user, let's say user 1 and user 2 matches, whether I should create user 1, user, what should I say? Yeah, user 1, user 2 record and user 2, user 1 record. So this is a bit kind of annoying problem because it can possibly the cause of the data inconsistency. So rather I would create younger user ID and older user ID. Yeah. So with this, okay, so this creates both swipe and match here. So to avoid the data inconsistency, it creates swipe and match if applicable in the same transaction. Yeah. So I will talk about this in detail when I talk about the non-functional requirement, strong consistency, but basically this should be done in the same transaction. Okay, and the last one, get match API. So I create another service here. So when match API, sorry, get matches API is hit, this match service fetches the match record. And for this, of course, we need the index here. And with this, user can fetch the matches, all the matches with, over again time. Yeah. And of course, maybe we'd like to sort the, you know, matches by the timestamp, or maybe, and maybe not. Typically, we sort the matches with the history of the message, last message. Sorry, timestamp of the last message between in the chat. So it kind of, let's just say, it totally depends on the specification, but maybe it's useful to add the composite index for younger user ID and match ID, match at, and also another composite index for older user ID and match at. Yeah, but I don't write it here. Okay, so these are the, yeah, high level design. And now this service has all the APIs. So, oh no, I forgot one more thing. So one thing I missed is about the notification. So when there is a match, the swiped user should be notified. So we need the kind of match notification service. And I will use the change data capture here. So with change data capture, notification service knows that there is a match. And let's say there is another user here who matched. So this user should be notified. So this notification service makes the API call to the third party notification service like Google Firestore messaging API. Or for the iPhone users, we need Apple notification service. Yeah. So either of these API are hit. So this is the third party API. So I make it gray. So this notification service hits this third party API. And now this third party API pushes the notification to the matched user. Okay, so this is a high level design. Yep. That being said, I finished my today's system design practice. Thank you so much. Bye.